NEET Cracker, channel of comprehensive concepts in physics, chemistry, and biology. Welcome to NEET Cracker, the ultimate channel for NEET exam preparation in physics, chemistry, and biology. Our channel is dedicated to providing you with mind maps and concise explanations of all the important concepts covered in the NCERT curriculum. We go beyond the core concepts, delving into the periphery of each topic to ensure you grasp the subject thoroughly. With our detailed videos in English, you'll be equipped with the necessary knowledge to crack the NEET exam with flying colors. 5 keywords: NEET exam preparation, physics concepts, chemistry concepts, biology concepts, NCERT curriculum. In this video, we will guide you through the essential concepts of physics, chemistry, and biology. Our aim is to enhance your understanding and provide the necessary foundation to excel in the NEET exam. We focus on the NCERT curriculum and go beyond to explore the depths of each subject. So, let's dive in and embark on this exciting learning journey together.
Hi guys, welcome to my channel NEET Cracker. On this channel we will be dealing with the examination NEET UG, and we will be covering all the subjects, that is physics, chemistry and biology, and all its chapters. So today we are starting with the most basic chapter of physics, that is vectors and scalars. So let's go. First of all, scalar is a physical quantity which has magnitude but no specific direction. Example: distance, mass and speed. Vector, the physical quantity which has magnitude as well as direction and follows the vector law of addition. Example: the force, velocity and displacement. Note 1. Current is not a vector quantity, though it has direction and magnitude, as it does not follow vector law of addition. Representation of a vector quantity. A vector is represented by drawing an arrow proportional in length to the physical quantity being represented. A vector variable is represented by an arrow over English or Greek alphabet. The same alphabet without the vector sign represents the magnitude of the vector, and the same alphabet with a cap sign represents the direction of the vector. Now there is a quick exercise for all of you. Okay, so here we have to find out sine 2 pi by 3. We know sine 2 pi by 3, therefore we know that pi radians is equal to 180 degree. So sine of 2 into 180 degree upon 3 is equal to sine 360 degree upon 3 is equal to sine 120 degree. Therefore sine 120 degree is equal to sine 90 degree plus 30. Therefore cos of 30 degree is equal to under root 3 by 2. Now there is a second practice problem for all of you, that is tan of 3 pi by 4. So tan of 3 pi by 4, we know that pi radian is equal to 180 degrees. Therefore tan of 3 into 180 degree by 4 is equal to tan of 540 upon 4 is equal to tan of 135 degree is equal to tan 90 plus 45 degree. is equal to cot 45 degrees is equal to minus 1. Now example number 3 is cos of 5 pi by 6. Therefore cos of 5 pi by 6, we know that pi radians is equal to 180 degree. Therefore cos of 5 into 180 by 6 is equal to cos of 150 degree is equal to cos 90 plus 60 degree is equal to minus sine of 60 degree is equal to minus of under root 3 by 2. Now let's move on to the fourth example, that is tan 2 pi by 3. Here we know tan 2 pi by 3. Okay, and we know that pi radians is equal to 180 degree. Therefore tan of 2 into 180 by 3 is equal to tan of 120 degree is equal to tan 90 plus 30 degrees is equal to cot of 30 degree is equal to minus of under root 3. So now let's move on to the triangle law of addition. To add two vectors using triangle law, place the tail of the second vector on the head of the first vector. Now complete the triangle and the resultant vector is given by the arrow starting from tail of the first vector to the head of the second vector as shown in the figure. This is the first vector, this is the second vector, and this is the resultant vector. Now let's look upon to example number 5. Therefore we have a vector is equal to 3, b vector equals to 4, and this is the resultant of the c vector. So according to the triangle law of addition, c vector is equal to a vector plus b vector. Tan theta or theta is equal to tan inverse of 4 by 3. We know that tan theta is equal to opposite upon adjacent. Therefore theta is equal to tan inverse of 4 by 3. For example, if a vector is equal to 1 kilometer north, then a is equal to 1 kilometer and a cap is equal to north. A cap represents simply the direction. Inverse trigonometric notation for angles. For point 1, sine inverse of x represents an angle whose sine is x. Example, tan inverse of x is equal to tan inverse of, say tan inverse of x is equal to tan inverse of 1 is equal to 45 degree. Sine inverse of 1 by 2 is equal to 30 degree. Radian measure of angle. 360 degree is equal to 2 pi radian. If the angle theta of an arc is expressed in radians, then the arc length is simply represented by L is equal to r theta. Okay, now let's look upon to the trigonometric ratios for angles greater than 90 degree. Sine of pi minus theta is equal to sine theta. Cos of pi minus theta is equal to minus cos theta. Tan of pi minus theta is equal to minus tan theta, and sine of pi plus theta is equal to minus sine theta. Cos of pi plus theta is equal to minus cos theta. Tan of pi plus theta is equal to tan theta. Here we have a note point, that is sine of 37 degree is equal to 3 by 5. Cos of 37 degree is equal to 4 by 5. Sine of 53 degree is equal to 4 by 5. Cos of 53 degree is equal to 3 by 5. Vector sum is commutative, that is a vector plus b vector is equal to b vector plus a vector. Now we look upon to the angle between two vectors. The angle between two vectors is defined as the non-reflex angle between the vectors when they are joined tail to tail. Example, the angle between the vectors is 60 degree when they are joined tail to tail, not 120 degree because they are not joined tail to tail. Now let's look upon the analytical addition of vectors. When we consider two vectors, a vector and b vector represented, for finding the resultant a vector plus b vector using the triangle law as shown in the figure. Using Pythagoras theorem, we get magnitude of c vector is equal to under root of a square plus b square plus 2ab cos theta from this figure. and the direction is given by phi is equal to tan inverse b sin theta upon a plus b cos theta. Now is the practice time for all of us. Okay, so here we can see that a vector is 5 units and b vector is 5 units from the x-axis. So the resultant is equal to under root of a square plus b square plus 2ab cos theta, where theta represents the angle between two vectors. We have here the theta is 45 degrees. So under root of 5 square plus 5 square plus 2 into 5 into cos of 45 is equal to under root of 25 plus 25 plus 2 into 25 into 1 upon under root 2 is equal to under root of 50 plus 50 upon under root 2 is equal to under root of 50 under root 2 plus 50 upon under root 2. So therefore this will be the resultant. Now let's find the tan alpha. So tan alpha or tan phi is equal to b sin theta upon a plus b cos theta. Okay, therefore 5 into sine of 45 degrees upon 5 plus 5 into cos of 45 degrees. Therefore 5 by under root 2 upon 5 plus 5 by under root 2 is equal to 5 by under root 2 upon 5 under root 2 plus 5 whole by under root 2 is equal to 1 upon under root of 2 plus 1. Therefore tan phi is equal to 1 upon under root 2 plus 1. Therefore angle phi is equal to tan inverse 1 upon under root 2 plus 1. Now we go for the next question, which states that a man walks 10 kilometers towards east and then another 10 kilometers towards 60 degree north of east. Find its resultant and theta means the direction. Okay. Now first of all we will learn what is north of east. What is 60 degree north of east? So if a man is going 10 kilometers is in the east direction and then 60 degree north of east means if we take the reference direction as east, then we have to go 60 degrees from north of east, means the angle between the resultant and the angle between the initial and the final vector must be 60 degree. So as we know the law of superposition of vectors, this will be the required figure and this will be the resultant. This will be angle alpha, means the direction of the man or the direction of the resultant. So therefore let's first find out the resultant. Therefore resultant vector is equal to under root of 10 square plus 10 square plus 2 into 10 into 10 into cos of theta, where here theta is 60 degree. Therefore we get 100 plus 100 under root of 100 plus 100 plus 200 into 1 by 2 is equal to under root of 300 is equal to 10 under root 3. Now let's find out the direction of this vector is equal to b sin theta upon a plus b cos theta is equal to 10 sin 60 degree upon 10 plus 10 cos 60 degree is equal to 10 into under root 3 by 2 upon 10 plus 10 into 1 by 2 is equal to 10 into under root 3 by 2 upon 20 plus 10 whole upon 2. Here we get under root of 3 upon 2 plus 1 is equal to under root of 3 upon 3. So therefore tan of alpha is equal to 1 upon under root of 3. Therefore alpha is equal to 30 degree or phi is equal to 30 degree. Now let's move on to parallelogram law of addition. Here we place the vectors tail to tail and complete the parallelogram. Now the resultant is given by diagonal of the parallelogram passing through the common tail. Note, for any given vector, a vector, the symbols a and magnitude of a vector mean exactly the same thing. From this diagram we can see this is a vector, this is b vector, and this is the resultant in context with the parallelogram law of vector addition. Here the c vector or the resultant vector equals to a vector plus b vector. Now we look upon to the polygon law of addition. Here we join all the vectors to be added in a head to tail configuration, and now the resultant is given by the vector joining the tail of the first vector to the head of the last vector. As we can see in this diagram, negative of a vector. Negative of a vector is a vector with the same magnitude but with reversed direction. For example, a vector is equal to 1 unit n cap, where minus a vector is equal to 1 unit s cap. Now we look upon to the subtraction of vectors. Subtraction is same as the addition of negatives. C vector or the resultant vector equals to a vector minus b vector, where c vector is equals to a vector plus of minus b vector. Here we can see that the magnitude of the resultant vector in vector subtraction is equal to under root of a square plus b square minus 2ab cos theta, where this is the a vector, this is the minus v vector, and this is the resultant vector. Unit vector, a vector having magnitude and some specific direction, is called unit vector. It is unitless quantity. Any vector divided by its magnitude gives the unit vector in the same direction. For example, if a vector is 5 km n cap and magnitude of a vector is equal to 5 km, then a unit vector is equal to a vector upon magnitude of a vector. Rectangular components of a vector. Whenever a vector is expressed as a sum of two mutually perpendicular vectors, then we call the vectors as rectangular components of the vector. There are infinite ways of doing this to resolve a vector into mutually perpendicular components. Imagine a rectangle whose diagonal is the given vector. The sides of such rectangle are the rectangular components. For instance, let there be a force F inclined at an angle theta with the horizontal. Then its horizontal and vertical components are given by Fx is equal to F cos theta and Fy is equal to F sin theta. From this figure we can see that this is the F vector, this is the angle theta with the x-axis, so the horizontal component is F cos theta and the vertical component is F sin theta. Now let's start with our first example of this topic, which is saying that resolve the weight of vector of the block in two components. So first we will try to resolve it in its parallel direction. Therefore, resolving the weight in its parallel direction is equal to mg sin theta. Here we know theta is 30 degrees. So mg, which is 300 into sine of 30 degree, is equal to 300 into 1 by 2 is equal to 150 Newton. Weight of the block in its perpendicular direction will be mg cos theta is equal to 300 into cos of 30 degree is equal to 300 into under root of 3 by 2 is equal to 150 under root 3 Newton. Now let's resolve this weight perpendicular and parallel to the direction of the actual weight acting. So if we calculate the weight perpendicular to parallel to the thread, that is equal to mg into cos of 37 degree, which is 100 into 4 by 5 is equal to 80 Newton. And if we calculate the weight perpendicular to the thread, which is mg into cos of into sine of 37 degree is equal to 100 into 3 by 5 is equal to 6. Now let's see the addition of vectors in Cartesian form. Let a vector and b vector be two vectors given by a vector equals to axi cap plus ayj cap and b vector equals to bxi cap plus byj cap, represented for addition of triangle law in Cartesian plane as shown, where a vector, b vector and c vector equals to a vector plus b vector. This is the horizontal component of the a vector, this is vertical component of a vector, this is the horizontal component of b vector, and this is the vertical component of b vector. This is the horizontal component of c vector and or the resultant vector, and this is the vertical component of the c vector or resultant vector. Let c be the resultant given by c vector equals to cxi cap plus cyj cap. Then it is evident from the figure that cx is equal to ax plus bx and cy is equal to ay plus by. For example, a vector equals to 3i cap minus 4j cap and b vector equals to 4i cap plus 8j cap. So a vector plus b vector is equal to 7i cap plus 4j cap. The vector k cap. To represent the location of a point in space, we need a third coordinate called the z coordinate, which represents the height or depth over the xy plane, which we need to travel to reach the desired point. This is called the z direction. The unit vector along this direction is the k cap. Here there is a funny example or a tricky example which we can see to locate the points in a three-dimensional space. So the A point is located at 6, 0, 0. Here the first digit represents the x coordinate, the second represents the y coordinate, and the third represents the z coordinate. This will be true for all these 7 figures. Okay, the B is located at a point 6, 0, 1. C is located at a point 0, 0, 1. D is located at a point 0, 4, 1. E is located at a point 0, 4, 0. F is located at the point 6, 4, 0. And G is located at a point 6, 4, 1. Now let's look upon to the position vector. The position vector of a point in space is defined as a vector joining the origin to that point. For example, R of G vector equals to 6i cap plus 4j cap plus k cap. Magnitude of a vector in 3 dimensions. Here we can see the magnitude of a vector. If a vector is axi cap plus ayj cap plus azk cap, then magnitude of a vector is equal to under root of ax square plus ay square plus az square. The direction cosine of a vector, the cosines of the angles that a given vector makes with the xy and z axis respectively. Cos alpha, cos beta and cos gamma are called the direction cosines. Here we can see cos alpha is equal to OF upon OC, which is AX upon magnitude of A vector. Cos beta is equal to AY upon magnitude of A vector, and cos gamma is equal to AZ upon magnitude of A vector. Therefore, we have two special formulas, which are cos square alpha plus cos square beta plus cos square gamma equals to 1, and sin square alpha plus sin square beta plus sin square gamma equals to 2. Multiplication of a vector by scalar. Whenever a vector is multiplied by a scalar, the magnitude gets multiplied and the direction remains same. If it is positive scalar, and direction reverses if scalar is negative. For example, f vector is equal to 6 n 6 Newton east and time is equal to 3 seconds, then F vector dot t is equal to 18 Newton seconds in east or minus of 18 Newton seconds in west. Displacement vector. If a particle moves from one position to another, then the change in its position vector is known as displacement vector. S vector or displacement vector is equal to final position minus initial position. RV represents the final position vector and Ri represents the initial position vector. For example, S vector is equal to 12 I cap minus 4j cap minus 3k cap. The initial position is equal to, or the initial position vector is equal to 4j cap plus 3k cap. The final position vector is equal to 12 I cap. So the displacement vector is equal to R final vector minus R initial vector is equal to 12 I cap minus 4j cap minus 3k cap. The magnitude of the displacement vector is equal to under root of 12 square plus 4 square plus 3 square equals to 13 meters. The dot product or the scalar product. Let there be two vectors A vector and B vector having an angle theta between them. Then we define their product as D is equal to AB cos theta, where theta is the angle between them, and this is A vector, this is B vector. For example, A vector dot B vector is equal to 12 of cos 37 degree is equal to 48 by 5. Dot product in the Cartesian form. I cap dot I cap equals to 1. I cap dot j cap equals to 0. J cap dot j cap equals to 1. J cap dot k cap is equals to 0. K cap dot k cap equals to 1. And k cap dot I cap is equals to 0. For example, F vector is equal to 6 Newton east and time is equal to 3 seconds, then F vector dot t is equal to 18 Newton seconds in east or minus of 18 Newton seconds in west. Displacement vector. If a particle moves from one position to another, then the change in its position vector is known as displacement vector. S vector or displacement vector is equal to final position minus initial position. RV represents the final position vector and Ri represents the initial position vector. For example, S vector is equal to 12 I cap minus 4j cap minus 3k cap. The initial position is equal to, or the initial position vector is equal to 4j cap plus 3k cap. The final position vector is equal to 12 I cap. So the displacement vector is equal to R final vector minus R initial vector is equal to 12 I cap minus 4j cap minus 3k cap. The magnitude of the displacement vector is equal to under root of 12 square plus 4 square plus 3 square equals to 13 meters. The dot product or the scalar product. Let there be two vectors A vector and B vector having an angle theta between them. Then we define their product as D is equal to AB cos theta, where theta is the angle between them, and this is A vector, this is B vector. For example, A vector dot B vector is equal to 12 of cos 37 degree is equal to 48 by 5. Dot product in the Cartesian form. I cap dot I cap equals to 1. I cap dot j cap equals to 0. J cap dot j cap equals to 1. J cap dot k cap is equals to 0. K cap dot k cap equals to 1. And k cap dot I cap is equals to 0. There is a note point. Dot product is distributive, that is A vector dot B vector, that is A vector dot in bracket B vector plus C vector is equal to A vector dot B vector. Now let's learn about the relative position vector. Let there be 2 points in space A and B whose position vectors are given by R vector A and R vector B. Then the position of B as seen from A is defined as vector joining A to B, which is called position of B relative to A, or RBA. As it is clear from the figure, position of B relative to A, it is given by R vector BA is equal to R vector B minus R vector A. Here we can see that this is R vector A, this is R vector B, and this is R vector B minus R vector A. Now practice time. What is R vector G, R vector C, R vector A, R vector CG, R vector E and R vector AG? Find angle between GA vector and GC vector. R vector G is equal to 2k cap. R vector C is equal to 2I cap. R A vector is equal to 2j cap. R CG vector is equal to 2I cap plus 2j cap, and R AG vector is equal to 2j cap minus 2k cap. Angle between GA and GC. Angle between GA and GC is equal to 4 upon 2 under root 2 into 2 under root 2. Cos theta is equal to 1 by 2, where theta is equal to 60 degree. Then second question, find angle between body diagonals of the cube, where OC vector is equal to 2I cap plus 2j cap plus 2k cap, and GB vector is equal to 2I cap plus 2j cap minus 2k cap. Therefore, OC vector dot GB vector is equal to 4 plus 4 minus 4 upon under root of 3 into 2 into 2 under root 3 is equal to 1 by 3. Here there is a note point that RAG vector is equal to GA vector starting from G to A. Projection of a vector on another vector component. Let there be two vectors, A vector and B vector, represented by lengths OA and OB. Then the projection of A on B is obtained by joining the two vectors from tail to tail and dropping a perpendicular from head of A on vector B, say point A. Now OA is the projection. As it is clear from the figure, projection of A on B is equal to A cos theta is equal to A vector dot B unit vector, or projection of A vector on B is equal to A vector dot B cap. Similarly, projection of B vector on A vector is equal to B vector dot A unit vector, or projection of B on A vector is equal to B vector dot A cap. Cross product of vectors. Let there be two vectors, A vector and B vector, having an angle theta between them. Then their cross product, C vector or the resultant vector, is given by C vector equals to A vector cross B vector, and magnitude is given by C vector is equal to AB sin theta, and the direction is given by right hand thumb rule or the right hand screw rule. Now let's learn about the right hand screw rule. Join the vectors to be crossed tail to tail and rotate a screw at the junction of the common tails from first vector to the second vector through the non-reflex angle. The direction of the rotation of the screw is the direction of the cross product. The right hand thumb rule. Place the palm of the right hand perpendicular to the palm of the vector such that the little finger is along the first vector, and curl the fingers points towards the other vector through the non-reflex angle. Now the thumb gives the direction of the cross product. For example, this is the A vector and this is the B vector. Now keeping the little finger on the A vector, we turn our fingers to the B vector. This is the direction. My thumb points in the direction of the resultant or the direction of the cross product of two vectors, that is the A vector and the B vector. We know that in the right hand thumb rule, the base of the palm or the wrist should be at the common tail. Now the cross product in the Cartesian form. I cap cross I cap is equal to 0. I cap cross j cap is equal to k cap. J cap cross j cap is equal to 0. J cap cross k cap is equal to I cap. K cap cross k cap is equal to 0. K cap cross I cap is equal to j cap. J cap cross I cap is equal to minus k cap. K cap cross j cap is equal to minus I cap. I cap cross I cap cross k cap is equal to minus of j cap. Now we can learn all these formulas from a single schematic figure. So I cap cross I cap is equal to 0. I cap cross j cap is equal to k cap. J cap cross j cap is equal to 0. J cap cross k cap is equal to I cap. K cap cross k cap is equal to 0 and k cap cross I cap is equal to j cap. Then j cap cross I cap is equal to minus k cap. K cap cross j cap is equal to minus I cap, and I cap cross k cap is equal to minus j cap. There is a note point that cross product is not commutative, so it follows this formula, that is a vector cross b vector is equal to minus of b vector cross a vector. Cross product is distributive, that is a vector cross in bracket b vector plus c vector is equal to a vector cross b vector plus a vector. Now we will learn about the matrix method for the cross product. Let there be two vectors given by a vector is equal to ax I cap plus ay j cap plus az k cap. B vector equals to bx I cap plus by j cap plus bz k cap. By multiplying out, we get this: a vector cross b vector is equal to ay bz minus az by I cap plus az bx minus ax bz j cap plus ax by minus ay bx k cap. To do the same process in an easy manner, we represent the data as shown in the following matrix and how the cross product is given by the determinant of this matrix. Here we have drawn the whole two vectors in a matrix form. Here I cap minus j cap k cap ax ay az bx by bz. Here is a note point: if the two vectors are parallel, then this cross product will be 0. Therefore ax upon bx is equal to ay upon by is equal to az upon bz. Antiparallel vectors are represented by this sign, but are vectors with equal magnitude and opposite direction. Lami's theorem. Condition for equilibrium. A body is said to be in equilibrium if the vector sum of all the forces acting on it is 0. Statement for Lami's theorem. Let a particle or a body be in equilibrium under the influence of the three forces Fa, Fb and Fc. Arrange tail to tail, then Fa upon sine of alpha is equal to Fb upon sine of beta is equal to Fc upon sine of gamma. Here you can see the proof of the Lami's theorem, which will be useful for your board examinations. There is a practice example for all of you. If these are the three wires, here a mass is attached and its weight is 100 Newton. The tension in this wire is T1, the tension in this wire is T2, the tension in this wire is T3, which is taken as T is equal to 100 Newtons. So according to Lami's theorem, T1 upon sine of 37 degree is equal to T2 upon sine of 53 degree is equal to 100. Therefore T1 into 5 by 3 is equal to 100 and T1 equals to 60 Newtons. T2 upon 4 into 5 is equal to 100 and T2 is equal to 80 Newtons. So like this video, share, subscribe and be happy always. Thank you.
Thank you for joining us today on Neat Cracker. We hope you found this introduction to our channel and mind maps informative and exciting. Don't forget to subscribe to our channel to stay updated with all our latest mind maps and NEAT exam tips. Remember, Neat Cracker is here to guide you towards success in cracking the NEAT exam. Visual display of subscription button and social media hand. Keep studying, stay motivated, and best of luck on your NEAT journey. See you in the next video.